Hello everyone. In this video, let us look into fermentation media. Though we have a very good strain in industries for the product production, fermentation media plays a very important role in increasing the product yield. The fermentation media or the culture medium or growth medium is a liquid or gel which is usually designed to support the growth of the microorganism. Now, fermentation media is such a culture medium which is used usually in industries to grow the microorganism and to produce the yield. Now, the fermentation media must satisfy all the nutritional requirements of the microorganism and it should fulfill the technical objectives of the fermentation process. In fermentation media, the nutrients has to be formulated to improve the synthesis of the target product. There are certain ideal characteristics of a fermentation media. So let's look into the ideal characteristics of the media. A medium that has to be used on an industrial scale must meet all the following criteria that is mentioned here. That is, it will give or it should give the maximum yield of a product or a biomass per gram of the substrate used. So if it uses 1 gram of a substrate, then it should at least produce 0.7 to 0.9 grams of the product. Only then we consider that the maximum yield of the product is being produced. It should not lead to the undesired product formation. There should be either minimum yield of undesired product or it should not yield any undesired product. The product should be of consistent quality, and when we are using a substrate for the media production, and this substrate should be available throughout the year, and this medium should cause minimum problems during the media preparation or during the sterilization of the media. So certain media will, when we are doing sterilization, it will precipitate, so such problems it should not cause. So it should cause minimum problems during media preparation and sterilization. It should also cause minimum problems during the downstream processing or during the product purification. Moving on to media formulation. Media formulation is an essential stage in the design of a successful laboratory experiments, in pilot scale development, and in various manufacturing processes. The constituents of the media must satisfy the elemental requirements for cell biomass and metabolic process, and there must be an adequate supply of energy for biosynthesis and cell maintenance. An industrial medium should contain all the essential requirements that is required for the production of the product or to increase the cell biomass. Now, the media usually contains a carbon source, a nitrogen source. If it is an aerobic fermentation process, then oxygen is required. Along with it, other nutrients like vitamins, minerals, and growth factors are also required. So all of this, when it is added into the media, then the media will, in the fermentation media, when we add all this, the media will give us a good biomass, enough of product, high yield of product will be produced. Along with it, some of the fermentation process, carbon dioxide, water, and heat will be released. So what are the different components of a media? Usually the fermentation media contain carbon source, nitrogen source, vitamins, minerals, growth factors, precursors, inducers, inhibitors, chelators, buffers, oxygen, antifoam agents, and so on. So all of these media components we will be seeing one by one in my further slides. So moving on into the carbon source. The carbon source is required for all the biosynthesis processes which leads to the reproduction, product formation, and the cell maintenance. Carbon source is the main energy source of a microorganism. In most fermentation processes, carbon source serves as the energy source. Now, the carbon source is required for the biomass production and to increase the yield. Now, there is something called as yield coefficient. Yield coefficient means what is the percentage of yield that is being produced, and that is called as yield coefficient. Yield coefficient is the ratio for the biomass produced to the carbon substrate that is being utilized. Say for example, if 1 gram of substrate is being utilized to produce 1 gram of biomass or 1 gram of product, then the yield coefficient is said to be 100%. If 0.8% of product is being produced for 1 gram of substrate being used, then the yield coefficient is said to be 80%. So yield coefficient is the percentage of the yield that is being produced. So it is defined by the ratio of biomass produced to the carbon substrate that is being utilized. So there are different raw materials that are used as carbon source in fermentation industries. Usually in industries we do not go for synthetic media, or we do not go for the purified form of carbon source or nitrogen source. Here we are going to use raw materials that can be used as a carbon source because these raw materials are cheaper. So the first thing is molasses. Molasses is a byproduct of cane sugar industries, which are during the sugar production in sugar industries, we get molasses as the byproduct, which is rich in carbon. So molasses can be used as a raw material for the as a carbon source. Then we use malt extract. The malt extract is the concentrated aqueous extract from the malted barley. During beer production or during beer production especially, we go for malting of barley. So malt extract can be used as a carbon source. Malt extract is usually used in beer production. Apart from this, we have starch and dextrins, which are extracts from the maize, which can be used as a carbon source. And there is something called a sulfite waste liquor, which is a byproduct of paper and pulping industries. Then we have cellulose, which are products from agricultural, forestry, domestic and industrial process. From there we get this cellulose. Usually from it is an agricultural waste, especially lignocellulosic waste, wherein hay that we use, that we grow for agricultural process. The hay contains a lot of cellulose in it. They are lignocellulosic material, so that can be used as a carbon source. Whey, which is an aqueous byproduct of dairy industry, can be used as a carbon source. Others like alkanes, alcohols can also be used as a carbon source, which are byproducts of petroleum industries. Fats and oils from animals or plants can also be used as carbon source because fats has a lot of carbon in it. So fats can also be used as a carbon source. Moving on into nitrogen source, most industrial microbes can utilize both inorganic and organic nitrogen sources. Now, inorganic nitrogen is supplied in the form of ammonium salts like ammonium sulfate, diammonium hydrogen phosphate, or ammonia. Ammonia is also used to adjust the pH of the fermentation. Whenever there is a change in the pH during the fermentation process, ammonia is used to adjust the pH during the fermentation. The organic nitrogen sources includes amino acids, proteins, and urea. Here again, nitrogen is often supplied in the crude forms as the raw materials. Various raw materials are used for as a nitrogen source. So the raw materials that are used as nitrogen source in industrial fermentation is usually corn steep liquor, which is a byproduct of starch extraction from maize. Then we use yeast extract, which is waste that is produced from bakery or brewery. Then we use peptones. Peptones are usually obtained from the acid or enzyme hydrolysis of products such as meat, casein, gelatin, keratin. So when we use enzymes or acids to hydrolyze meat, casein, or gelatin, we get peptones. So peptones can be used as the nitrogen source. Peptones are also used in laboratories as a nitrogen source to prepare synthetic media. Also we use peptones. Soya bean meal can also be used as a nitrogen source. Soya bean meal is a residues of soya beans after the extraction of oil. Apart from carbon source and nitrogen source, minerals are also very important for the fermentation media. All microorganisms require certain mineral elements for growth and the metabolism. In many media, magnesium, phosphorus, potassium, sulfur, calcium, and chlorine are essential components, and because of the concentrations that are required, they are added as distinct components in the media. This manganese, phosphorus are all added as distinct components. Other minerals such as cobalt, copper, iron, manganese, molybdenum, and zinc are also essential. Now, these minerals are usually present in the raw materials that we are using only. So the raw materials contain all of these minerals, but some of this like cobalt and all will have to be added into the mineral as mineral into the fermentation media. Apart from this, vitamins and growth factors are also important in fermentation media. Many bacteria can synthesize all necessary vitamins from basic elements. For other bacteria like filamentous fungi, they must be added as supplements to the fermentation media. Many of the natural carbon and nitrogen sources used in media formulation, they also contains all of the minerals and the growth factors that are required for the growth of the microorganisms. So vitamins and growth factors will be present. Minerals also will be present in the raw materials that we are using. So therefore, it is not always necessary to add it as a supplement in the fermentation media. So in my next video, we will see the other components of the fermentation media like precursors, inducers, and elicitors. Thank you all.